Okay, lesson 2.2, creating and solving equations. So this has been something I've kept emphasizing to you over and over and over again. You've got to be able to solve equations, but the difference is here we've got to create them from verbal descriptions. So a lot of word problem type things. So you'll want to pay attention to some of the verbiage and different things like that. We can't go over all of it. We're just going to try to highlight parts of it here as we go on. So again, a good thing to do would be to look at these examples that they give you here, especially for some of the terms. We're just going to do some of the homework problems again to emphasize this. Here's a great example of when you solve where you have variables on both sides. So again, that would be useful to you possibly in reviewing a little bit. So here, looking at how to use tables to help you, different things like that, some problems with pictures involving geometry. So a lot of different things here that we'll be going over. So we're going to real quickly, just going to pick some of these problems to do under the homework section. I'm going to start with problem number 3, the difference. Okay, so there's a word we need to know. Difference means subtract. So the difference between a number, so a number, what is our number? I don't know, we'll say n. So the difference between a number and 12 is means equals, and we've done this in some review stuff, is 20. So there would be our equation. Now the directions here just say write an equation, so we're not actually solving these, we're just writing an equation down. Okay, let's go on down to question number 5. 2/3 a number. 2/3 a number. Okay, 2/3 is a fraction. So 2/3 a number, so n, plus 4 is 7. There's our equation again. So again, not solving, just translating. Okay, what about a more specific word problem like number 7? Hector is visiting a cousin who lives 350 miles away. He has driven 90 miles. How many more miles does he need to drive to reach his cousin's home? So obviously this is an easy problem to do, but in terms of writing the equation, we know he's driven 90 miles. We're looking for how many more miles he has to drive, x, and altogether that has to be how far it is, which is 350. So that would be our equation that we would use to try to solve. Now again, you could find the answer very easily. Alright, let's get a little bit more complex here. Let's go to problem number 11. It says 1 month, Ruby worked 6 hours more than Isaac. Svetlana, whatever, worked 4 times as many hours as Ruby. Together they worked 126 hours. Find the number of hours. So this becomes more difficult because we're talking about 3 different people. Ruby, Isaac, and Svetlana. Alright, so how do we do this? Well, one of the things I've tried to emphasize to you before is whenever you're writing problems with variables, make the variable represent the thing you know the least about. So let's look at the information. Ruby worked 6 hours more than Isaac. Svetlana worked 4 times as many hours as Ruby. So who do we know absolutely nothing about? We don't know anything about Isaac. So there's our variable. So I'm going to say Isaac, I can't write, sorry. Isaac, I'm going to say is X number of hours. Okay? So if Isaac is X number of hours, then I'm going to write one for Ruby based on Isaac. What's it say? Ruby worked 6 hours more than Isaac. So that would be X plus 6. 6 more means we add. Then I'm going to write Svetlana. Okay, it says Svetlana worked 4 times as many hours as Ruby. Well, what was Ruby? Ruby was X plus 6. So I have to put that in parentheses because all that is Ruby. Now it says together they worked 126 hours. So together means I add. So Isaac plus Ruby plus Svetlana equals 126. So there's our equation. Now let's go back to the directions up here at the top. It says write and solve. So I do have to solve this one. So I'm going to work this equation out. So I do distributive property here. So I get x plus 6 plus 4x plus 24 equals 126. Look for my like terms. Those are like terms. And these are all variable like terms. So I'm going to do a little bit of quote-unquote erasing here. I'm going to create some space here to write some more underneath this. So then I've got 6x plus 30 equals 126. Subtract 30 from both sides. 6x is 96, divide by 6, and that's going to give us x is 16. Okay, now read the question. Find the number of hours each person worked. So if x is 16, then that means Isaac worked 16 hours. Ruby did x plus 6, so 16 plus 6 would be 22. So Ruby worked 22 hours. And Svetlana would be 16 plus 6 is 22, times 4 would be 88. She worked 88 hours. Now, a good thing to do, always check your answers. So take 88 plus your 22 plus your 16, and make sure all that adds up to give you 126. And it does. It does give you 126. Alright, let's continue on. Let's go to problem number 13. I'm not very good with these names. Zion and his cousin Kai both collect stamps. Zion has 56 stamps. Kai has 80 stamps. The boys recently joined different stamp collecting clubs. Zion's club will send him 12 new stamps per month. Kai's club will send him 8 new stamps per month. After how many months will Zion and Kai have the same number of stamps? How many stamps will each have? Okay. So what do we not know? We don't know after how many months. So that's our variable. What I know is Zion, I'm going to use red for him, he has 56 plus he gets, Cyan gets 12 per month. 12 for each month. Now what I'm looking for is I'm looking to see where they have the same number, so they're equal. So I'm going to use blue for Kai. So it says Kai has 80 stamps, and then Kai gets 8 stamps per month. Alright, so we have a variable on both sides. So now, what do? I always try to move the smaller variable, so I'm going to subtract 8m from both sides. So that's going to give me 56 equals, I'm just going to do it all in red now, 80. Sorry, let me erase that. I forgot my variable here. 56 plus 12 minus 8 is 4m equals 80. Then get rid of my 56 here. So then that gives me 4m equals 24. I'm going to do a little bit of erasing here, create more space again. Alright, so then we have 4m equals 24. Like I said, divide by 4 on both sides. And that gives me m is 6. So the first part of the question, after how many months will they have the same number of stamps? 6 months. The second part of the question asks how many stamps will each have. So what I have to do is I've got to go back and plug 6 in. What I should do is plug it into both and make sure I get the same amount. So if I do 6 times 12, that's 72. 72 plus 56, I believe, is 128. Let's do that here. 6 times 8 is 48. 48 plus 80 is 128. So they would have 128 stamps each. So quite a bit involved here. So we're going to speed up a bit. We're going to go down here to problem number 19, where we have to read a table. So it's asking us to use this table to answer the question. It says Paul started work at Company B 10 years ago. So Company B, what happens? You get a starting salary of $30,000 and then an increase of $2,400 each year. At the same time, Shirley started at Company C, or Charlotte, sorry. So I'm using Paul in blue. I'm going to use Charlotte in red. Company C. So she started out more, but her yearly increase is a little less. Who earned more during the last year? How much more? Okay, so how do we figure this out? Now, you could do it year by year, but that would take a long time. So for Paul, we started out at $30,000, plus he gets $2,400 each year. Now, how many years did he work? He worked 10 years. So that would give us Paul's amount. So we do that. That's going to give us 10 times 24. We give us 24,000 here, plus the 30,000 he started with. So that'd give us, sorry about that, $54,000 after 10 years. Okay. What about Charlotte? Charlotte started at 36 and then gets 2,000 for the 10 years. So that's 20. 20 plus 36 would be 56,000. So who earned more during the last year? Charlotte did. In the last year, Charlotte's making 56,000 to Paul's 54. How much more? That's $2,000 more. Okay, let's go on to problem number 21. A geometry problem here. Sammy bought enough fencing to border either a rectangular plot or square plot. As shown, the perimeters of the plots are the same. How many meters of fencing did she buy? Okay, so we're talking about perimeter. It says the perimeters are the same. How much did she buy? So if the perimeters are the same, that means they're equal. Now, how do you get perimeter? You add all the sides together. So I take the perimeter of the square. So I'm going to use black here for the square. So it's x plus 2. Now, since it's a square, all of these are x plus 2 each side. So I could do x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. Or I could just do x plus 2 times 4. That has to equal the perimeter of the rectangle. The rectangle is 3x plus 2 on this side and x minus 1 on the other. So 2 times x minus 1 plus 2 times 3x plus 2. So now I have to solve this. So I do distributive property here. So as I do that, that's going to give me 4x plus 8 equals 2x minus 2 plus 6x plus 4. Add my like terms. So I'm going to skip some steps here. This is why, again, you need to be able to solve equations because there's a lot involved. And the faster you can solve equations, the better. I'm taking a little bit of time here in these videos to just do some review and solving. Okay, so look for our like terms. And right here we have like terms, and right here we have like terms. So I get 4x plus 8 equals 2x and 6x is 8x. Negative 2 and 4 is a positive 2. Again, I move my smaller variables, so I'm going to subtract 4x from both sides. Gives me 8 is 4x plus 2. Get rid of my 2 by subtracting. It's going to give me 6 is 4x. Divide, oops, messed up there. I put 6x. That should be just 6. Okay. There you go. Sorry about that. And so we divide by 4. Oops, that's too big. divide both sides by 4. And then if I reduce that, that's 1.5 is x. Now, that's not how many meters of fencing, that's what x is. So then what I have to do is go back and plug it in. So if I go back and plug it in, that's going to give me 1.5 plus 2 is 3.5. I multiply that times 4 because it has 4 sides. And that's 12 and 2, so that'd be 14 meters of fencing. Now a good thing to do would be do it down here and make sure you get 14. Alright, one last problem. Problem number 24. Again, these explain the error problems. I think these are real good. So all we're going to do is we're going to evaluate here both these individuals' work and look and see where the error is. So we take step by step, just evaluating. So obviously we got to do distributive here. So 5 times x is 5x, 5 times 20 is 100, half of 4 is 2, half of 4 is 2. Okay, now we look at Brittany. Well, something I notice here, the expression is different. So as I look at the work, move 2x over 3x, add 100, 102 divide 34, move the 2x over, negative 7, move the 100 over, negative. Okay, I get two different answers, all because this expression is different. So now what I got to do is I got to read the problem and see who wrote it wrong. It says 5 times the difference of a number in 20. 5 times the difference of a number in 20. Difference means subtract, of a number in 20. So Kevin is right. A number in 20, their difference. Brittany is wrong. That would be the difference of 20 and a number. Now that brings us to a good point. One phrase you need to know when it's subtraction is the phrase less than. And when it's less than in subtraction, that is the one time you have to switch the expression. In other words, if I say x less than 4, then I don't write x minus 4. That would be incorrect. What I write is 4 minus x. Whenever it says less than and it's implying subtraction, you have to switch the order of the terms. Here, problem number